So in this lecture we'll take one example of friction. We already have done that example with the case when there was no friction present, but now let's say there is friction on the surface of the table. So we already have solved this kind of problem, but let's additionally put friction on the table. So this is the problem. This guy is 20 kilograms, this guy is 5 kilograms, and we have to find the acceleration A. Now we can, from common sense, we can say that A should be downward. This guy is pulling the 20 kilogram mass, will be able to pull the 5 kilogram mass. It should not be like that. So this is illogical. So you may have to invoke some logic before you start solving problem of friction, because this is the other problem we'll discuss, but let's talk about it right now a little. If we have problems like these, then let's say if this is 12 kilograms, then this is I don't know, 18 kilograms, or maybe not 18. Let's call this 18 and let's call this 12, and this angle, let's say, is I don't know, 60. Then we do not know whether this guy is moving down or this guy is moving up. So are you going to label it A like this or A like that? Well, it did not really make difference when there was no friction, because if you assumed A like this and A turned out to be negative, you sort of understood that A, you should have labeled A like that, but I mean, it doesn't really make any difference. It still gives you the right answer, because A equals 1.2 down is same as A equals minus 1.2 up. It's the same thing, right? So so there was no discrepancy in this case. But for friction, you see, if you assume A in different directions, you solve a different problem. Why? Because if you take A downward, friction is going to act like that, while if you take A up, then friction is going to act like this. Why? Because in the first case the body is moving like this, in the second case body is moving like that. Friction always opposes the motion. So friction has changed direction, and because it has changed direction, the two problems are different, entirely different, because you have different free body diagrams in both the cases. So if you start by solving a problem and it turns out that A is a negative number, then you cannot really say it's just the reverse. That means you took the wrong, you started with the wrong direction of acceleration, and you need to resolve the problem with the right direction of acceleration, right? So let's solve this problem right now. I mean, these are little difficult problems which you may not really encounter, but these problems which are properly posed will not really be requiring a lot of argumentation. You can just solve it using simple standard method. So let's solve this problem right here. Again, whenever you have a mechanics problem, draw free body diagrams. First of all, you already have identified the constraint that if this guy is moving down with acceleration A, this guy should be moving forward with acceleration A. If you make free body diagram of 20 kilogram mass, you see there is a force of gravity 20g acting, and there's a tension which is acting. Similarly, if you draw a free body diagram of 5 kilogram mass, then you see there's a tension acting like this. There's a normal reaction acting like this. There's a force of gravity which is acting like this, and there's a force of friction acting like this. Will be what? Mu n. Because the body is already moving, mu is actually mu k, and let's take mu k, let's say it's given to be 0.1, and you can see that friction, maximum friction force is given as mu n. If it's moving, then it's mu k, which is the kinetic coefficient of kinetic friction, and n is the normal reaction. So this is mu k here. Friction is acting to its fullest because the object is moving. So these are the two free body diagrams. Once you have free body diagrams, you can write Newton's equation. And to write Newton's equation, first you have to define the axis system for each body. So let's call this x, let's call this y, let's call this y, let's call this x. So if you write, and what are the Newton's equation? Newton's equation are max may. So let's talk about this mass, 20 kilogram. For 20 kilogram mass, you see there is no contribution from the x-axis. There are no forces acting in the x direction, and there is no acceleration in the x direction. So we really don't have to worry about this equation for 20 kilogram mass, but we can worry about this equation for 20 kilogram mass. So let's write Newton's equation for that one. So it's going to be T T is in the positive y direction, minus 20g equals, we have assumed A to be in the negative y direction, should be 20 minus A. And let's try writing for 5 kilogram mass. For 5 kilogram mass, this equation will be T minus mu n equals 5A, and the y equation will be n minus mg equals 0. So there is no ay. Okay, how to solve this? Well, you can see you can replace n. We already know n is mg, which is, sorry, it should be actually 5g, because m is 5. That gives us n equals 5g. We have to solve these equations, substitute the value of 5g, so that gives you t minus mu is, well, mu is actually mu k, 0.1 multiplied by 5g equals 5a. That gives us t equals 0.5g plus 5a. Okay, now use this equation and substitute it here. So what you get? You get 0.5g plus 5a minus 20g equals minus 20a. And if you rearrange this, you get 25a equals 19.5g. That gives you a equals 19.5 over 25